Okay, so we've just deployed the software to the target machines. Now, the best thing to do now is just wait for a few minutes. Let the software establish the cache and start providing benefits. It'll only take a few minutes. Maybe go and grab a cup of tea or a coffee or something and then come back. And then we can start pulling the report data from velocity on those machines to the velocity management console. And the way to do that is to hit this select systems button here at the top. Okay, and it'll show us the machines that have velocity installed. And if you've got a big list of those, just hit the first checkbox next to system name and it'll enable all of those at once. Now when we hit the save selection button, the management console will reach out to those machines and say, give me your latest, most current dashboard report data. And then after a few seconds, it'll display that in an aggregated form on the console for you. Now, it's worth having a quick look through this because this is a really good way of seeing what the software is doing for those machines. So here on the top left, we can already see the total number of storage I/O requests that our software was able to eliminate from having to take that trip out to storage and back again. You can see the amount of reads that were eliminated and the amount of writes eliminated. Reads can be satisfied from the RAM cache. That's a memory to memory transfer. Very, very fast. RAM is much faster than pretty much any kind of storage you're likely to have on the back end, including flash and SSDs. We've got many customers that are using this technology over all flash arrays and seeing fantastic results. Now you can also see how much storage time, how much storage processing time has been saved by the storage not having to process these IOs that we were able to eliminate from having to take that trip out to storage and back again. So this is basically the number of IOs eliminated multiplied by how long it was taking IOs to be satisfied at the time the IOs were generated. I hope that I've explained that well enough, but yeah, this is basically all the time that the storage didn't have to spend processing these IOs. Freeing up storage time means you're freeing up resources. You're helping to reduce storage latency. You're handing additional IO headroom back to the environment for you to use now with additional workloads. So that IO reduction might mean that you can now host more machines over that same back-end storage than you otherwise would have been able to do. If you've got any storage bound applications, so applications that really can only run as fast as the storage will allow them to, well, now they'll be able to get more work done in the same amount of time, just simply because they're not having to wait so much on the storage before being able to get on with their next operation or transaction if it's a SQL database. We also have this IO performance tab here, which we can click on for even more information about what's going on. So here we can see the average, minimum and maximum for things like the IOs per second, the throughput in megabytes per second, how much data is being transferred per second. We can see what the storage latency looks like. How long is it taking to satisfy storage requests? We can see if the workload is more read heavy or more write heavy. In this case, it's a little more read heavy, 61% read IO traffic to 39% writes. That's going to vary depending on your particular workloads. We can see how much storage workload was generated and processed, and we can see of the memory that's there, how much is being left free on average and how much we're using for RAM caching purposes. And we also have this analytics tab here, which shows some very helpful bar charts. Unfortunately, there's not going to be a great deal of data in those at the moment because I've only just installed the software to those machines, as you saw in a previous video. But after a day or two, these will fully populate. And you'll be able to see what an average 24 hours looks like. So you'll be able to see things like what time of the day are we eliminating most of that storage IO traffic? What does the IOs per second look like at different times of the day? When is the storage busier than at other times? You can see how much storage traffic or how much of that read IO traffic we're satisfying from the RAM cache. So those reads that get satisfied at the speed of RAM rather than the speed of the media in the backend storage and the network connecting it back to the physical servers. And there's a whole bunch more bar charts and analytics on here as well, including this one here. How much storage time is being saved at different times of the day? Does that match up with your peak workload time so that you're getting the most benefit at the times that your workloads need it the most? Now, of course, you are very welcome to share these results with a conducive engineer, and we'll happily go through it with you and explain each part of the reports and really see how it's benefiting your particular workloads. Just reach out to us and let us know. We'll be more than happy to help, and we'll provide you with an engineer like myself to go through that with you. Again, you can get in touch with us by going onto our website at conducive.com/contact, and then any of these contact details will allow you to get hooked up with an engineer in your particular region. So I hope that helps, and I hope that helps you get the most out of the testing and the trial that you want to do. Let us know how we can help. Thanks, everyone. Take care.